let's go on and go over the review sheet. So we're going to look through these problems here. So do you have any questions on 1 or 2?
Hey, she's selling water if y'all want to. 4th of July class.
Yep. So let's look at this here. Any questions on problems number 1 or number 2? Problems on the first 2 problems. Or one of those that y'all want to see work. Number 1. So if we look at this one here, we do see that there is a greatest common factor between the 3 terms. Now on the test, greatest common factor will be part of, you will get points deducted if you don't find the greatest common factor, if there is one. So up to this point so far on most of the assignments, I've been a little bit lenient. I've given you guys at least one mistake if you've had one and not counted off. Also, I haven't been really counting off for greatest common factor too much, because on some of them, I gave it back. I showed there's a greatest common factor here you needed to factor out, but didn't count off for it. On the test, the greatest common factor will be worth a point. So if you do find it, but don't find the greatest common factor, you are able to factor it, you will get a majority of the points. You just won't get the one for greatest common factor. So for most of them, that means you'd get probably 4 out of the 5 points. You'd get 80% of that problem. So that's one thing to look out for. Now, not every problem will have a greatest common factor, but the ones that do, it will need to be factored out. So if we look at this first one here, okay, this first one here, we can see that there is at least A and B in common in all 3 terms, because all 3 terms do have an A and all 3 terms do have a B. Now, if we look at the A terms, well, we have A cubed, A, and A squared. So the most I can take out of any 3 terms is actually just A. Now, if we look at the B terms, well, I have B squared, and B squared. So we can factor out a B squared. Now, if we look at the constant terms, 6, 36, and 71, well, there's not a greatest common factor with our numbers. So all we can factor out, or our greatest common factor for this here, is A times B squared. And we can go on and factor it out of each term. Now, the 6 is going to stay because we didn't actually factor out a number. We're just factoring out A and B squared. Now, for our first one, we have A cubed, and if I remove 1 from it, I will have A squared. Then when I factor B squared out of B squared, well, it factors out completely. So the next would be our minus 36, because again, we didn't do anything with the numbers, so they will stay the same. Now when I factor 1A out of A, well, it factors out completely, and the B squared will factor out completely, so we just have 36. Plus 71A, because if I factored A out of A squared, I'm left with 1A, or just A to the first, and the B squared would factor out completely. Now, before I do anything else, I do want to write this in standard form, so that would be 6A squared plus 71A minus 36. Okay. Any questions on this here so far? To write it in standard form. You got your review sheet?
No, I don't have that.
There's the one over there.
Oh, there it is. Sorry.
You're good. Now at this point here, it actually works out that we are finished, because the quadratic 6a squared plus 71a minus 36 is actually not factorable. One of the ways that we can check is with b squared minus 4ac. And if we plugged in 71 for b minus 4 times 6 times negative 36 in this here, and we could plug the whole thing into the calculator. Squared minus 4. Yes? Yes. This here gives us 76.843. Continues on, which tells us that this quadratic is not factorable. So this is as far as we can go by just factoring out the ab squared. Now we're not going to have one exactly like this here, because any of the ones where we can't, or we just factor out a greatest common factor, what's left over inside the parentheses, you should be able to tell by looking at it that it won't factor. We won't have something like this here where it looks like it could. Any questions on this here? Any other questions on the first two problems? We good with this problems 1 and 2? Yes? Any questions on 2 and 3? Or one of those two that you all want to see worked out? 3. So when we look at this here, we need to see if there is a greatest common factor. And there's not going to be one between a squared, 4a, and 4. So we can go on and set up our 2 sets of parentheses with 3 spaces. Now the next thing we can do is find the sign. Since our third term is positive, the signs are the same and they match the sign of the middle term, which is also positive. So we're going to have plus and plus. At this point here, we need to find the factors of a squared and the factors of 4. Well, the factors of a squared are a and a, because there's only one set. Now the factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. And if we check this here, a times 2 is 2a. 2 times a is plus 2a, and 2a plus 2a is 4a, which is exactly the middle term that we wanted. So this here is our factors. Now if we wanted to, we could also have written the answer as a plus 2 squared, because they are both the exact same thing. So we can write it in either way. Any questions on this here? Well, you realize when they do that, it just means that you're doing this online instead of in person.
Yeah. Feel like I'm at home. I passed last semester with like a B.
Any other questions on these two here? Or one of these that you want to see worked? We good with number 2? Or 4x squared plus 12x plus 9? Okay. Any questions on 4 through 7? questions on one of these four? We feel good with these four? Okay. Questions on 8 through 11. Questions on 8 through 11 are one of those that y'all want to see work. 10. 10's not going to show up on the test because it's not a difference of perfect squares. It actually doesn't have any factors, or shouldn't. Yeah. 10's not factorable. So it's just staying the same answer. I'm going to fix that later and take that off the review sheet. It wouldn't be a difference of perfect squares because they're not being subtracted. So there's nothing we can do to it. Huh? Yes. Now, when we look at 11, we can, there is an x squared that's in common with all three terms, so we can factor it out. And there is a greatest common factor of 7. So we can factor this out of all three terms. So when we factor 7 out of 49, we're left with 7. X squared. Because 49 divided by 7 would be 7. And x to the fourth divided by x squared would be x squared. Plus 343 divided by 7 is 49. And x cubed divided by x squared would be x. Plus 1. Because 7 divided by 7 would be 1. X squared divided by x squared would also be 1. It factors out completely. And that's actually as far as this one goes. Because the 7x squared plus 4, or 71x plus 1, 7x squared plus 49x plus 1 is not going to factor. And we could actually check it with our 49 squared minus 4 times 7 times 1, because this is not going to be one of our natural numbers. It's not going to be a whole number. It will have a decimal. More specifically, see here, 49 squared minus 4 times 7 times 1. It gives us 48.7134 going on. So this does have a greatest common factor of 7x squared, but that's it because this other part does not factor any further. Any other questions on these here? 8, 9, 10, or 11? 8. Well, we do have subtraction, so there's a chance that we do have a difference of perfect squares. Well, 8 and 72 are not perfect squares, but is there a greatest common factor between 8x squared and 72? 9 won't, 8 won't divide by 9. I think you mean the other way around. What times 9 is 72? So what's divisible by both 8 and 72? 8. Because there is a greatest common factor of 8 between both. Because 72 divided by 8 is 9, and 8x squared divided by 8 is x squared. So there is a greatest common factor of 8 in both of these here. And if we factor that out, it leaves us with x squared minus 9. Well, x squared minus 9 is the difference of perfect squares, yes? So our difference of perfect squares would be our two sets of parentheses. And we'd have what? X We have plus or minus, because we can say plus what? And we'd have x minus 3. Because the difference of perfect squares is following the form of a minus b squared is equal to a plus b times a minus b. Where a and b are just whatever the number multiplied by itself would be. So for x squared, it's x and x. For 9, it's 3 and 3. And this would be it here. Any other questions on any of these so far? Questions on 12, 13, 14, or 15? So this here, we do have a cubed and b cubed. So most likely we're looking at the sum or difference of perfect cubes. So what we can do is take the cubed root of both of these here. So we take the cubed root of 375, a cubed. And we can take the cubed root of 192, b cubed. And if we take the cubed root of 375, it turns out that that's not a perfect cube. It's going to give us a decimal. So we need to look back at both of these here and see, is there a greatest common factor between both? Well, 3 will go into both of these. 375 divided by 3 is going to be 125 a cubed plus 192 divided by 3 is going to be 64b cubed. Okay. Now we can try the cubed root again. I'm taking the cubed root of 125 a cubed. And well, the cubed root of 125 is 5, and the cubed root of a cubed is a. Now we can also take the cubed root of 64 b cubed. Well, the cubed root of 64 is 4, and the cubed root of b cubed is b. And we can type those into the calculator. So it says that we can take that this here is the sum of two cubes. So for us, we would have 3, parenthesis with 3 spaces, and then our parenthesis with 5 spaces. And the signs for the sum or difference of perfect cubes go in the same pattern of same, opposite, always end on a positive note. So since we're starting out with plus, the same would be plus, opposite would be minus, and we're going to end on a plus. Any questions on this so far? Now our first set of terms will be dealing with the 5a. So in the first spot we'll have 5a. Here we're going to have 5a squared. In the middle we'll just have 5a to the first, and the last one would technically be 5a to the 0, but we don't include that one there. Now our other term is 4b. So in the first set of parentheses, we would have 4b. Here we're going to have 4b to the 0. In the middle, we'll have 4b, and in the last one, we'll have 4b squared. And the last thing we need to do is to simplify. So we'd have 3 times 5a plus 4b. Now, over here we have 5a squared. Well, 5 squared is 25. And a squared is, well, a squared minus 5a times 4b. Well, 5 times 4 is 20. And then we would have a b plus 4b squared. 4 squared is 16. And then we have b squared. So this here would be the final answer. Any questions on this here? Any other questions on 12, 13, 14, or 15? Am I good with these here? Questions on 16, 17, or 18? Do we feel good with these here? Okay. Questions on 19, 20, 21, or 22? Now, when we look at these two here, we need to see if there's a greatest common factor between them. Now, one of the greatest common factors that is between them is y. There is a y in common with both terms. I'll go on and tell you that there's also a greatest common factor of 2. 2 will also go into both terms. So if we divide them both by 2, well, the first one here would be 15, 625 x cubed minus 6 . Now at this point here, we need to take the cubed root of both terms to figure out what they are. So 15,625 x cubed. And the cubed root of 46,656. Now the variable is pretty easy to take the cubed root of. Okay, the cubed root of x cubed is x. Now the cubed root of 15,625 x cubed is, well, 25x. And the cubed root of 46,656 is actually 36. So that means that we can factor this as this difference of 2 cubes. Now what would our signs be for this here? First one would be minus, because they're going to be the same. Since we started out with the negative, we would start off with a negative. Our next one would be plus. And our last one would be plus, because we're going to go same, opposite, always end on a positive note. Now with any of the sum or difference of perfect cubes, we will always have 2 addition signs and 1 subtraction. Now let's plug in the first term. Well, the first one to appear would be our 15,625, which would be our 25x. So on the first spot, we would have 25x. Now in the first parentheses, we're going to have 25x squared. The middle one will just have 25x. And then we won't have a number taking spot in the last one because it would be 25x to the 0, which would be 1. Now the other number we're going to be plugging in is our 36. So here we'll have 36. In the middle, we'll just have 36 to the first, and in the last one, we'll have 36 squared. Simplifying. Well, the first set of parentheses is not too bad to simplify. So it's just going to be 2y times 25x minus 36. Now the next one, well, the first thing we're going to have to do is take 25 squared. And 25 squared is going to be 625 x squared plus, we're going to have to do 36 times 25, and we could do that in a calculator, and it would tell us that it's 900 with our x, plus 36 squared is going to be 1,296. And that would be it there. Cold? Any questions on these here? Any questions on 23, 24, 25, or 26? Questions on any of these four here? 25? Yeah. This here is different because we do have four terms, so we're going to have to use factoring by grouping. Now, the way that we group them really doesn't matter, but what we can do is the first two and the second two. We can just group them that way, first two and second two. And look for the greatest common factor between these two. That is a V. So the greatest common factor between 25 and 5 is 5. And the greatest common factor between v cubed and v squared is v squared. And that will leave us with, because 25 divided by 5 would be 5. And v cubed divided by v squared, or factoring v squared out of v cubed, will leave us with v to the first, or v, plus, well, 5 divided by 5 is 1, and v squared divided by v squared is 1. So we're left with 5v plus 1 when we factor out 5v squared. Plus, what are we factoring out between 30v and 6? 6. 30 divided by 6 is? We would have v. Plus 6 divided by 6 is? So what's in common with both of these here is 5v plus 1, and we can factor it out of both. If we factor it out of the first, we're left with squared. And this would be it here. It would be good to make sure and look at the parentheses with the v squared, 5v squared plus 6. Now, if we only have two terms, we're either looking at the difference of perfect squares or the sum or difference of perfect cubes. Well, v is a squared, so it might be a difference of perfect squares. But for it to be a difference, we need what? Subtraction. This has addition, so that doesn't factor any further. Any questions on these here? Let's look at the last two here, 27 and 28. Is there one of these that we want to look at? 28. Well, this here is a little bit different because we do only have two terms. But is there a greatest common factor between them? It goes into both 15 and 30. Yeah, 5 does, but also 15, and we would have x, because they both do have an x. Now, on the first one, 15 divided by 15 is 1. X squared divided by x, or if we factor an x out of x squared, we're left with plus. 30 divided by 15 is 2. And the x will factor out completely, leaving us with this here. Now, what's inside the parentheses is to the first power. So we're done. That's all we have to do with this here. Well, we can look at the other one as well. What's the greatest common factor between 12 and 144? And then we would have x squared. Well, 12x squared factored out of 12x cubed would leave us with minus 12. Because 144 divided by 12 is 12, and the x squared factors out completely. Any other questions on this here? Well, let's just look at one more. Let's say x to the fourth minus 2x squared plus 1. Now, we could actually factor this similarly to how we factor other trinomials, even though it does have a fourth degree for the first term and a square for the middle term. We don't need it. I have no idea. I decided to switch ink halfway through. Now, since the third term is positive, the signs would be the same, and they would match the sign of the middle term, which is negative. So we can say minus and minus. We'll look at the factors of x to the fourth here in a minute, but the factors of 1 are 1 and 1. Now, the factors of x to the fourth are either going to be x times x cubed or x squared times x squared. But x times x cubed is not going to work because when we do the distributive property, our middle terms would have, one would have x and the other would have x cubed. So the factors for this here that are going to work are going to be x squared and x squared. Let's get a different color. Now we can check this here using our distributive property. It is x squared times negative 1 would be negative x squared. Negative 1 times x squared would be negative x squared. And negative x squared minus x squared is negative 2 x squared. Is that the middle term that we wanted? So it does factor. But both of these do have a square in them, and they're being subtracted. Is x squared and 1, are they both perfect squares? Well, yes. So this here, this first one here, is the difference of perfect squares that we can factor. And what would it factor to? X plus what? 1 times x. Wait a minute. In this other one also the difference of perfect squares? So this would also be x plus 1 times x. So we'd get something like that there. Any other questions on any other part of the review sheet? That is all we are going to do for today. Your test is tomorrow.